second week will be in offline. So the detailed schedule has been sent to all the participants. So for this, I appreciate the interest of all the participants. More actually, response will be more, but due to this physical session, so many participants are not getting on duty in their colleges. So because of that, they are not registering this program. Right. So on behalf of our Vivekananda College of Engineering and the departments, I welcome all of you. So with this brief introduction, so I request our principal, Dr. K.C.K. Vijay Kumar, to address the gathering. Sir, please.
Yeah, thank you, Saravanan. Am I audible?
Yes, sir. You are audible, sir.
Yeah. Okay. So good evening to all the participants and as well as the resource person professors. Ashok Kumar sir. Hello.
Yes, sir. Good evening.
Yeah, good evening. Good evening, Ashok Kumar sir. Yeah, good evening to all of you. Indeed, it's a great pleasure to discuss with you all today in this inaugural of Dr.L FTP program. Before a brief about this program, as said by our Dr. Kannan, HOD of Tripoli, we should sincerely acknowledge the support rendered by AICTE Dr.L FTP program, and we should also thank our management for magnanimously supporting whatever the program which is related with the faculty development or anything related with the student, they are magnanimously supporting. So I sincerely thank our management and as well as our executive director sir, who was instrumental behind all the development towards the stakeholders like faculty and student. And I also congratulate and appreciate the Department of Tripoli VCW headed by Dr. Kannan and all the fellow faculty members and as well as the staff members and students who meticulously prepare this FTP, FTP. And of course, I should also thank all the resource persons headed by Dr.L Ashok Kumar today. He joined it and he is going to give some introductory remarks about this particular FTP, like electrical vehicle. And thanks to all the management and the faculty member who are taking interest on this particular FTP and going to participate for this 2 weeks FTP. One is on online, another one is on offline. Of course, it is a really challenging organizing such an event in a blended mode. During the pandemic, we did it very well, but when you look back, it is really a very tough task for the people, particularly convener, to fix the guest and as well as the maintaining the entire decorum of participant throughout the 2 weeks program. So thank you, Ashok Kumar, for voluntarily given your time this evening time particularly. So thank you all the resource persons who are going to give share their views with respect to electrical vehicles concern. And thanks to all the participants, as I said. So without your participation and effective utilization of this particular 2 weeks FTP, it won't be the purpose for which it is being sponsored and recommended won't be survived. So please, whatever the sharing of information happening here in this platform, both online and offline, please forward it to the next generation, particularly student and even to your colleagues of your department. And this electrical vehicle, everybody will accept this particular topic is very emerging in the recent past years, and it is going to rule for the next near future also. One topic is electrical vehicles. So this electrical vehicles, it is it's inseparable nowadays. Even common man are utilizing this electrical vehicle to the extent. Earlier days, this electrical vehicle is being only for demonstration purpose or only in the highly intellectual areas like institutions and universities or some learned people only used to use this kind of thing. But now it is become now very common, and everyone is, even I would say every day we can able to witness that at least a couple of electrical vehicles crossing either the milk vendor or paper distribution boy, or every people are willing to do this electrical vehicle. So there are certain challenges and opportunities associated with the electrical vehicle. So those things, I hope it is all meticulously planned by the convener and as well as directed by ATEL, AICTE. This thing will be addressed in these 2 weeks program, both online and offline. And we are trying our level best to give the industrial exposure also. It's a part of this FTP. Hope the arrangement will be comfortable for all the participants, and even for the people who are going to share their views with our participants as well. So with these few words, once again, I thank all the people who are instrumental behind this FTP program. I also specifically thank Dr. Ashok Kumar, who is going to be the first speaker of this FTP. Thank you, Professor, for taking effort to participate in this late evening. Thanks for the opportunity, and special appreciation to the EEE of VCEW, Vivekananda College of Engineering, for organizing this program. So thank you. Over to moderator.
Thank you, sir. Thank you very much. So, today's speaker, Dr. L. Ashok Kumar, Professor, Department of Electrical and Electronics Engineering, PSG College of Technology. Dr. L. Ashok Kumar is a postdoctoral research fellow from San Diego State University, California. He is a recipient of Bhavan Fellowship from Indo-US Science and Technology Forum. His current research focuses on integration of renewable energy systems in the smart grid and wearable electronics. He has 3 years of industrial experience and 17 years of academic and research experiences. He has authored 6 books in his area of interest. He has published more than 110 technical papers in international and national journals and presented 107 papers in national and international conferences. He has completed 12 Government of India funded projects, and currently 5 projects are under progress. His PhD work on wearable electronics bagged National Award from ISTE, and he has received 12 awards in the national level. Dr. Ashok Kumar has 3 patents to his credit. He is a member and in prestigious positions in various national forums. He has visited many countries for institute-industry collaboration and as a keynote speaker. He has been an invited speaker in 110 programs. Also, he has organized 56 programs like conferences, seminars, and workshops. He completed his graduate program in Electrical and Electronics Engineering from University of Madras and his post-graduation from PSG College of Technology, India, and Masters in Business Administration from IGNOU, New Delhi. After completion of his graduate, he joined as a project engineer in Several Paper Boards Limited, Coimbatore. Presently, he is working as professor in Department of EEE, PSG College of Technology, and also doing research work in wearable electronics, smart grid, solar PV, and wind energy systems and electric vehicle. He is also a certified chartered engineer and BSI certified ISO 50001-2008 lead auditor. So we are fortunate to have such an eminent speaker for today's session. So on behalf of all the participants and the Department of Electrical and Electronics Engineering, Vivekananda College of Engineering, so I wholeheartedly welcome Dr. Ashok Kumar. So please, sir, the session is, please hand over, I hand over the session to Dr. Ashok Kumar. Sir, please.
Sir, thank you. Good evening all. I thank the principal for the inaugural speech as well as for inviting me for this AICTE ATAL FDP. And also I thank Dr. Kannan for doing so. So I'll be handling 2 sessions for you. One will be in the offline mode and another will be in the online mode. Sir, hope my audio is clear to you.
Yeah, it is clear, sir. You go ahead,
Okay,
sir.
I have not shared the screen. I'll be doing it now. So, as I said, I will be having two presentations. One will be on the online mode and another will be in the offline mode. And the main objective of these two presentations will be in the offline presentation, that is online presentation, that is today. I'll be talking more on power converters for electric vehicle. One. And two, we have done a project related to wireless charging infrastructure for electric vehicle. So I'll be discussing these two concepts today. So the outcome of this presentation would be people would be interested to do projects related to power converter side. So many of you would have worked on power converters for different applications, solar, PV, wind, etc. And there are more scope for you people to do research in the area of power converters for electric vehicle specifically. And secondly, the charging infrastructure plays a major role. One of the hiccups what we face in electric vehicle technology is the charging methodology. So wireless power transfer is another concept, and we have done it for an electric vehicle. It is already there. Only few of the countries have implemented it physically and still in research level in many of the places. So this is a prototype we have developed for electric vehicle concept. And apart from these two concepts, I'll be sharing some views on BMS, one of the important concept, not only for electric vehicle technology, but wherever you have a battery, you need to manage it properly. Even if you have a mobile, you should manage it. Otherwise, the battery life or the life expectancy of your mobile phone devices will get degraded. So how do I do this by BMS? In short, BMS means battery management system. What are the techniques available? So this will be my concept of my presentation. And during the physical mode, I will be talking more on artificial intelligence requirement for electric vehicle. So that will be the second session, and I will be coming on from 19th. So during that, how artificial intelligence, that is ANN, machine learning and deep learning, played an important role in electric vehicle technology, and how you academicians can contribute to it, how to start a research work in these three concepts. So my entire presentation will focus mainly on two aspects. One is understanding the basics and how to do research in the concept of electric vehicle. See, we are all academicians. It is not possible for us to do the business. Even we can, ACT is promoting the faculty members to start startups. So this can also be an eye opener for the people who want to do some business related to electric vehicle technology. Many scopes are there. We are doing BMS business. One of my student, he has started a business. He has completed his graduation from PSG College of Technology. He has started a own company in the field of lithium ion, and they are not manufacturing lithium ion, but they outsource from China and different country, and they will assemble it, and they have their own full setup. They have all the sophisticated equipments for testing it as per the standards required for electric vehicle. And apart from that, that is one part of one vertical of the business. And second vertical would be on developing BMS. So I insist you people to develop concepts, develop projects related to battery management system. We have a lot of scopes. Okay. So with this short note of the presentation, I would like to share my presentation to you. Please guide me if you have any trouble, if you face any trouble. Yeah. Kannan sir, my presentation is visible to you, right?
Screen is clear, sir. Visible, sir, and it is also your voice is also clear. You go ahead.
Yeah. So the topic, as I told you, power converters for electric vehicle, design, safety, and charging methodologies. This is the topic. And as Sir said, I'll be talking for 1 hour, and I'll give a break in between, and then we can have a short presentation, and we'll complete the session with the question and answers. So as you all know, electric vehicle and its importance, I no need to repeat the story again. by 2050 or by 2030, at the earliest, you will be seeing more electric vehicle in the market, and more manufacturers will start moving towards the concept of electric vehicle. But the main challenges in the electric vehicle concept is battery and how to maintain that battery package. The real problem in battery is how long my vehicle will go, and what is its required charging time, and what is the total cost of my vehicle. So if you can able to um, manage these three concepts, electric vehicle will be a successful model. So the main concept is the battery package, and it should have enough energy to drive your vehicle. And apart from driving the vehicle, it should have long driving range. Then only I'll prefer it. If I go for a very high speed, then the battery should be in a position to manage it. And in order to calculate the energy consumption of an electric vehicle, we need to properly model the components required for an electric vehicle. So for modeling the electric vehicle, there are different softwares available. This is not the correct podium to tell those softwares, but a lot of open source softwares available in the market. You can do mini projects, final year projects in that. And with that open source software, you need to model main components like transmission system, electrical machine, power electronic converter, and battery. So each and every component needs to be properly modeled to prevent the high consumption of energy. The design rating of each and every component will be calculated as per the design parameter. So it is basically a simple concept. Force is equal to mass into acceleration, right? We know that Newton's law. So if I want to move a particular mass, what is the force required for moving it? What is the force required for propelling that mass? And at what speed I am going to move that mass? So F is equal to mass into acceleration. Here the mass I refer to the electric vehicle, and the acceleration I refer to the speed. And the force, what it was represented in Newton's law, is a linear force. But in the case of an electric vehicle, we need the rotational force, that we call it as a torque. So once we decide the total mass of the vehicle and total speed, the velocity of the vehicle, it will be easy for you to decide the torque of the vehicle. So with this basic design parameter, you will be able to design an electric vehicle. Let us say I need a 7 kilowatt machine. So 7 kilowatt DC machine, 7 kilowatt AC machine, 7 kilowatt PMSM, 7 kilowatt SINRM, 7 kilowatt SRM. So depending upon the motor we prefer, the corresponding converters may vary. And depending upon the total mass of the vehicle, the battery requirement may vary. Right? So this is the basic thing we need to know. This requires not a rocket science. It is a basic common sense. So what is the force required? Force, I mean the rotational force equivalent to the torque. And what is the mass of the vehicle? And what is at what speed my vehicle will run? So if I able to calculate, if I able to decide the design parameter of the electric vehicle, it can be easy for us to model it. So what is the purpose of modeling? So once you decide the design parameter, you will be simulating it with a different simulation softwares for the corresponding transmission system, for the motor, for the battery, and for controlling the battery or controlling the motor, you will require a converter. For example, for controlling the battery, you may require a DC-DC converter. For controlling the motor, you may require an inverter or again a DC-DC converter. So before implementing it in a practical way, you need to simulate it. What is the purpose of simulation? You will be doing some trial and error method, and you will be doing so until and otherwise you get the required results. After getting the required results, what you have to do is you have to check whether the designed parameters component are available in the market. We normally used to call it as a COTS, commercially available off the shelf components. Okay, that is called as a COTS. So you can design anything. It's like a cartoon, right? In cartoon, anything can happen. Similarly, while designing it, while simulating, you can design and simulate anything. But what is available in the market, that is the main requirement, right? So you need to check the availability of the component in the market. And based on that, you have to move it for the next stage, that is the practical implementation. Okay. Oh, I hope I have given an enough introduction. So the purpose or the concept of electrical vehicle was started. In fact, it was started even before the Second World War in the 1900s. And after the invention of internal combustion engine, people stopped using it. And there was a very big oil crisis happened in the world in the year 1970 as well as in the year 1990. After that, people started to think back, and again they have started to use electric vehicle, and they found the benefits of electric vehicle as it has a very less fuel consumption, very low emissions, and we have different options for fueling, and of course it has high performance. So because of that, people started to move towards electric vehicle concept. And you know the benefits of driving electric, say we can even to save money. So now, as I told you, even faculty member can do business. As I told you, many foreign investors, many local vendors started to invest money in battery charging infrastructure. So in near future, in national highways, I think many of the vendors, they have already started this business. In near future, in national highways, you can able to see many charging station, and the charging station, apart from the place allocated for charging your electric vehicle, it may consist of full mall, like eating spot, shopping spot, playing area, parking area, etc. The purpose is simple. Your vehicle requires some time for charging, and during that time, let us say 15 minutes, 20 minutes, half an hour. During that time, you can finish it off your shopping, you can finish it off your food, etc. So this is going to be a huge market in near future. Okay, and the benefits of driving electric is we can observe very good environment. We no need to pollute the nature, and we have energy independent. I no need to believe in petrol, diesel, or gas. Okay, and of course we can enjoy the ride because it has. I no need to bother much on the fuel. I can able to charge whenever wherever I want. I no need to bother about the petrol charge, the petrol tariff, etc. So of course I can enjoy the ride. So if you look back the history of an electric vehicle, the concept was started, to be frank, it was started once the rechargeable battery was invented in the world. It was started in the year 1859. And using that rechargeable battery, they have replaced the bullock carts with a rechargeable battery, and they have invented a vehicle that is an electric vehicle. And in 1900, the people produced electric cars in masses. Okay, and in the year 1910, the first internal combustion engine came into the market. Once the internal combustion engine came to the market, people started to believe in ICE because I can I can drive the internal combustion engine at a very high speed. I no need to bother about the charging. I no need to bother about the battery life, and the fuel is available very easily during those period, and the cost of the fuel is also very less. Okay, less maintenance. All these things made people to completely forget about electric vehicle, and they moved towards internal combustion engine based vehicle. And from 1920 to 1920, gasoline powered car take over the entire automobile market. And as I told you, in the year 1970, there was a first oil crisis occurred in the world. And everywhere it was very tough for people to move because of the oil crisis. And they again started back to think about this electric vehicle concept. And again, because of the Gulf War, I think many of you know, in this group of people can understand. They will understand. In the year 1990, Gulf War was started because of Saddam Hussein, and there was a very big oil crisis happened. And the next year, 1991, LPG was introduced. I think here LPG means liberalization, privatization, and globalization. And many foreign car manufacturers invested money, and they have promoted their cars in India. So all these came to Indian market. The history of the automobile sector, there was a drastic change. Earlier days, we used to see only Contessa ambassador cars. And after 1991, in the year 2000, I mean, just before 2000, the Maruti 800 was introduced to India, and luxury people started to buy a Maruti 800, and slowly all the foreign cars came into Indian market. Now you know the history behind Tata and Jaguar, etc. Right? Now, all the car manufacturers, right from Tata to Ola, they have started to invest money in electric vehicle market. Okay, now that is the story. So these are all the different types of electric vehicle available in the market. The first electric vehicle is internal combustion engine based, and they have slow, because of the advancement of electronics, because of the evolution of electronics, they have introduced the automation concept. And for starting, they have introduced the automation, and that is called as a micro hybrid. And slowly, an electric motor supports the combustion engine, and that we call it as a mild hybrid. And they have two sources. One is diesel, another one is petrol, not petrol, petrol and gas, and petrol and car. So everything, when we have more than two sources, then it can be called as a hybrid. And if you use battery and if you plug in with the help of a grid or any other charging station, then it can be called as a plug-in hybrid electric vehicle. And if you source an alternate source for running your electric vehicle, for extending the range, then it can be called as the range extended electric vehicle. And if we have completely battery or fuel cell, it can be called as a full electric vehicle or a battery electric vehicle. So these are the types of electric vehicle available in the market. And these are the kinds of electric vehicle already existing in the market. Even before 1970s, these are all existing, but we might have not noticed it. For example, elevator, we can call it as an electric vehicle. Any device which moves or displaces anything from one place to another place, then it can be called as a vehicle. So in that case, forklifts, I think in industry, you might have seen that forklifts operates in 192 voltage. Okay, there is mainly used for logistics operations inside a premises of an industry. And golf carts, locomotives, submarine, and in some of the states, it is mandated that all the public utility vehicle, PUVs, should operate only with the help of electric vehicle concepts, buses. Okay. And these are the kinds of electric cars. I have just given a few examples: hydrogen-based hydrogen fuel cell based electric vehicle, solar-based electric vehicle, hybrid, full-size battery electric vehicle. And apart from that, different vendors are starting new innovations in designing, ergonomically designing an electric vehicle. I have shown few. And this is a slide to mention the history of electric vehicle. As I told you, in 1830s, battery electric vehicle was invented by Thomas Davenport. Okay, and they have used rechargeable battery, and they were ruling the entire world for automobile sector till 1900s. And EVs outsold gas cars 10-1. You see the market potential of electric vehicle during those period. And in their 1904, first speeding ticket was issued to a EV driver. The purpose of saying this is the electric vehicle, the concept, the technology used in 1904, even when the electronics was not that much familiar, even during that stage, electric vehicle was run with a very high speed. Okay, you see the date, you see the year 1904. And in 1910, mass-produced Ford cars undercut hand-built electric vehicle, and EVs persist as status symbol and utility vehicles until Great Depression. So this is the entire history of electric vehicle. And I'm going to show you two slides, 1968 and 1970s. The first electric car race was conducted from Massachusetts Institute of Technology and California Technology. And that is called, still people are doing this, conducting these races. That race, we call it as a transcontinental race, mainly using electric vehicle. During that time, 53 charging stations, and all the cars, they have used nickel cadmium battery. Now we are not supposed to use cadmium. So even though the performance of nickel cadmium battery was good, we are not using it. And in the year 1970, another race, we call it as a clean air car race. Again, from MIT to California Technology. They have used a different technology for electric vehicle, like regenerative braking concept. I think many of you know about this. Whenever you apply brake, we will be having certain energy. Energy can be neither be created nor it can be destroyed, but it can be transferred from one form of energy to another form of energy. So if I apply brake, I'll be generating some energy, and that energy can be converted to electrical energy. That concept we call it as a regenerative braking. That was used by California technology. And Boston, they have used the battery swapping method. This is going to be one of the successful model if they find a suitable business model called as battery swapping. Meaning is, I'll be having a battery in my car, and once the battery gets drained out, I'll go to a particular charging station. Instead of charging my battery, I'll just replace it. I'll just swap it. Okay. And this will be a good model for public utility vehicle, public buses. But for our own used vehicle, this will be creating a lot of troubles, because I will be having a new battery, and what if I replace with the old battery? So these are all the hiccups available in battery swapping mode. They may find a suitable method for solving these issues. And Toronto uses a different architecture. There are different architecture used by different cars, different car manufacturers. Similarly, MIT also used different architecture. So you know the purpose and need of an electric vehicle, like because of the environmental concern and practical concern. Lot of hackathons for the faculty member who are all interested. Lot of hackathons are being conducted by different universities and different colleges. We are developing. I am doing 3 projects related to electric vehicle. One is on battery management system. Second one is on power converters for electric vehicle. Third one is on EMI issues in electric vehicle. So all these are all government funded projects, and all the funding agencies are ready to give fund to academic people for projects related to electric vehicle. So I request you people to concentrate more on projects related to electric vehicle. And if you are interested, you can come and visit the laboratory at PSG Tech. We have developed a few converters. I have written a book on the title Power Converters for Electric Vehicle. I'll show it at the end of my presentation. So in that, we have discussed about different converter topology and how to simulate and how to design a converter for a particular vehicle application. And we have done a few hardwares. And after doing the hardware, what are the parameters to be measured? Unlike other converters, which is used for different applications, what are the required parameter and what are the standards? It is very, very important. Some of the converters require a few standard which is suitable for electric vehicle applications. So these are all the practical thing as a faculty member we need to do for the build of the nation. Okay. And benefits of EV, as you all know, now people are talking about energy efficient motor. I think many of you know, but IE4 motor. IE means instrument efficiency 4 motor. And earlier we used to have the efficiency of motor in terms of 70 to 85%. And now IE4 motor will have efficiency in terms of 90 to 95. And people started to manufacture IE5 motors. That efficiency will be in the range of 95 to 99%. If that is the case, the overall performance of an electric vehicle will get increased, obviously. And another thing is, as I told you, when you apply a brake, that energy can also be converted to an useful energy, which can be used for charging the battery. And hybrid electric vehicles are completely environmental friendly. These are all some of the benefits of going electric. So now technically, this is the structure of a hybrid vehicle. So one of the main component of a hybrid vehicle is the battery. And there are different storages available, but let us concentrate only on battery. And another one is the motor. Okay. So unlike the gasoline engine, we have a fuel tank, and the fuel tank can power only the internal combustion engine. But the electric motor on a hybrid car can run on battery as well as draw energy from them. Okay, it can able to charge the battery, it can able to run on battery. And different manufacturers may place the battery in different places inside the car. It's their design, it's their ergonomic design. Okay, So, but concept is the batteries will be used for running my motor, and the motor will run the transmission system. The transmission system in turn drive the car. This is the whole structure. So in this picture, we can understand very clearly the architecture of an electric vehicle. So we have a transmission system. I think this block diagram is visible to you. Could not move this. Anyway, I think you can able to understand the block. This is the transmission system. And this transmission system, hope my pointer is visible. This transmission system is run by an electric machine. There are different types of electric machine that we can discuss it later. And the electric machine is supplied by an inverter. And this inverter is being supplied by a battery, right? And the battery is being charged by the grid. So before coming into the grid, from the grid, it goes to the rectifier, and the rectifier gives an input to the boost converter, and we have an auxiliary load also. The converter gives the supply to the battery. Battery will be, the DC will be converted to AC with the help of an inverter and runs the machine. So this is the complete architecture. So how do I control the machine? The torque and speed of the machine is being controlled by the inverter. So on the whole, I need to control the inverter so that the car will run. Similarly, whenever the car applies a brake, when the user applies the brake, that energy can be converted to the corresponding DC voltage and it can be used for charging the battery. That concept we call it as a regenerative braking. So my point here is the entire system will have mainly three components. One is the machine, second one is the converters, and the third one is the battery. Okay. And the fourth one is the charging methodology. Here I have included grid source as a charging source. We can also have a solar PV system or any other source as a charging infrastructure. Any doubts here so far? If you have any doubts, you please open up or you put it in the chat box. I would like to answer all the questions. Any doubts so far? There is a message in chat. No. Any doubts so far?
No, sir.
Thank you for the response. Okay. The next topic would be on 1 second. Control of hybrid electric vehicle. So there are different types of controlling architecture. The first patent, 1 second. Okay. So the first patent was filed by American scientist H. Piper. He filed the patent of controlling hybrid electric vehicle technology in the year 1905. And now there are numerous patents available in the area of controlling hybrid electric vehicle concepts. There are different configurations of electric and hybrid vehicle. For example, electric vehicles equipped completely with battery and supercapacitors. We call it as a battery electric vehicle. I'll tell you the importance of supercapacitors later. A lot of research scopes available in supercapacitors. And hybrid electric vehicle, which combine conventional ICE with petroleum fuel and electric propulsion system. That we call it as a HEV. And electric vehicle equipped completely with hydrogen-based fuel cell or PEM, proton exchange membrane fuel cell, etc. So the concept of hybrid electric vehicle with ICE mainly aims to overcome the disadvantage of pure electric vehicle, because whenever you drive it in a very long range, your battery might get discharged quickly. During that time, your alternate source will take over the engine or take over the motor, and it may run the motor. So that is the main advantage of hybrid. But how do I vary the source? Who will take care of it? A layman can do, he cannot do this concept, right? So he knows how to drive the vehicle, but he no need to understand the concept of controlling a hybrid electric vehicle. So this automatic transmission system will take place inside the controller. So there are different techniques. Some of the technique might be a simple controller based, a PI controller based. Some of the controller technique will work based on PID, and some of the controller will work or mimic like human being, that we call it as artificial neural network. And some of the controller require a complex fuzzy logic system, okay, a neural network system. And some of the controllers may work based on the machine learning technique. There are different machine learning algorithm. Machine can learn by itself based on your usage, based on how you drive the vehicle daily, at what speed you drive. So the machine can understand by itself, and the machine can able to run your vehicle. And certain algorithm will able to predict when your machine will stop, when your electric vehicle will stop, what are the diagnostic procedures you need to do. And that we used to call it as a deep learning algorithm, that I'm going to talk in my next presentation. So there are huge problems involved in electric vehicle, and that can be solved by a simple control mechanism. Okay, very simple control mechanism. Anyone can do it. As I told you, right from proportional controller to the predictive analytic based technique, different control algorithms are available for hybrid electric vehicle. So these are all the main components of electric vehicle. As I told you earlier, battery, the charging infrastructure, converter, motor, and we have two types of charger, on-board charger and off-board charger. We will discuss that. And the corresponding power electronic converter. And the topic which I am not going to discuss today is thermal system. It is be a very, very important topic. I'll try to cover today. If not, I'll be covering it during the offline presentation. And of course, we have a different traction battery pack and the transmission system. So this is the basic working principle of an electric car. Like you have a motor. Motor will be useful for driving the entire vehicle by using differential transmission system. And motor is being controlled by a motor controller. Motor controller gets its supply from the battery, and battery gets it's getting charged from the charger. Charger, we have different protocol, which is we follow UK protocol. Each and every country follow different protocol. We follow UK protocol. And apart from that, the control mechanism. Here, the speed pedal is used for controlling the torque and speed of a motor. Okay. The torque and speed of the motor is being controlled by the inverter. So what is electric vehicle basically? If you see, this is the conventional vehicle architecture. We have a transmission, and the fuel will run an engine, and the transmission will take place. In the case of a hybrid, we have two sources, battery and fuel. In the case of a battery electric, I don't have any fuel and engine mechanism. Completely the transmission system will take place with the help of battery MG set. And there are different architecture, different structure available, series structure, parallel structure, and series parallel. Okay, 1 second. So series structure, if you see in the picture, at any point of time, only one flow of power will be from one source, like battery, inverter, motor, onto the transmission system. And during the battery is fully drained out, then engine will take over. It will give supply to the inverter, and it runs the motor. Engine will not directly run the transmission system, but at any point of time, it goes through the process of inverter and it runs the motor. This is called as a series hybrid. In the case of a parallel hybrid, it has two sources, battery and engine. Anyone will run the system, okay, or both can run the system in parallel. So it has two sources. This is called as a parallel hybrid. And we have one more propulsion that is called as the series parallel hybrid system. So it's equally being distributed. User doesn't know in which mode it is being operated. So we have a battery as well as engine, and we have, whenever you apply brake, the generator will generate energy and it can give back to the battery for charging. And during the running of the electric vehicle, Onboard charger in turn will charge the vehicle, and anything can happen. It's quite costly, quite complex as well. So this is called as the series parallel hybrid system. So this is the definition of an electric vehicle. I would like to try a portray using a picture. So electric vehicle, battery electric vehicle. You have an electric motor and a battery and a plug-in system. In the case of a plug-in hybrid electric vehicle and extended range electric vehicle, we have this system. We'll see in an animation. So in the gasoline engine, what it does in the case of a hybrid electric vehicle is during the normal process, combustion engine will run the system, and motor will be used for running the vehicle. And once the battery is fully charged, combustion engine supply will be cut off, and the motor will run with the help of a battery system. Okay, and this process continues. So we have two sources, combustion engine and a battery. Okay, once it is being drained out, combustion engine again will take over, and this process will be in a closed loop operation. In the case of a plug-in hybrid electric vehicle, we replace the small battery with an additional capacity, and we will plug it in with the charging infrastructure, and it gets fully charged, and again the process will goes on. Okay, so this is an important slide. Hybrid electric vehicle and how we researcher can contribute, how we academicians can contribute to the improvement of electric vehicle. So this is the transmission system, as I told you. I need to run this transmission system either with internal combustion engine or a motor. If I did it with internal combustion engine, then it can be called as the conventional electric vehicle. But here I have two sources. Which one to choose? That is being decided by the controller. So that is the control mechanism of an electric vehicle. So I can use different types of motor, like what? DC motor, induction motor, permanent magnet synchronous motor, switch reluctance motor, synchronous reluctance motor, hub motor, etc. That depends on what type of vehicle you choose and what is the capacity of the vehicle. And these motor being controlled by a suitable converter, like DC-DC converter, inverter, multi-level inverter, Zeta converter, etc., SEPIC converter, etc. And this converter, inside that converter, I will be using different type of switches like MOSFET or an IGBT. Instead of MOSFET, IGBT, silica based, I can go for a silicon carbide based. It is also yet another research topic now. Silicon carbide, we call it as a wide bandgap devices. The purpose of going for wide bandgap devices based semiconductor materials are, it has high energy density and it may have less EMI problem. Okay, it can carry more current. Another thing is the type of storage system you choose. I can go for a battery, ultra capacitor, fuel cells. And I have the motor, I have the converter, and I have the storage. How will I control? I can go for either microprocessor, microcontroller, DSP, DSC, DSP, FPGA, SoC, ASIC. Sorry, not SoC, SoC, ASIC. Different type of hardware control unit I can choose, and mainly for controlling the entire system and for having a separate dedicated BMS, battery management system. So depending upon the complexity of the control mechanism, I can go for either neural fuzzy, direct torque control, FOC, VVF. All depends upon the type of control mechanism I choose. So this is the entire architecture of an electric vehicle. So if you need any clarifications in any one particular topic, I'm ready to answer. Let me wait for 1 minute. If you have any questions, you please tell me now. Any questions, please? Any questions so far?
So clear, sir. No doubt, sir.
Okay. I know it is very tough to listen to the class after 7 o'clock, but anyway, it's my duty to ask Fine.
So this is Venkatesh. Energy storage, you have mentioned about fuel cell. How
Yeah.
fuel cell can store energy, sir? Fuel cells generate energy.
Yeah, of course, of course. So thanks for the question. Normally, there are two types of fuel cells is being used. One is PEMFC, proton exchange membrane based fuel cell. And another one is like we have hydrogen based fuel cells. What people will do is like it will be available in terms of kilowatt. They will have a separate process mechanism for this fuel cell technology, and that can be used as a replacement of the battery. Okay. From every cell, we will be getting a voltage in terms of 1.1 volt, 3.7 volt, except depends upon the capacity of the fuel cell. We will be having an array of fuel cell, and that fuel cell can be used as an alternate for the battery. It is available. People are using it, sir.
Thank you, sir. Good.
And another thing, since you have asked about the fuel cell, another storage mechanism people choose is ultra capacitor or a super capacitor. The purpose of super or ultra capacitor is you will be having a battery. As I told you, in the case of an induction motor, we have an option of regenerative braking system. Meaning is whenever you apply a brake, that energy can be converted to kinetic to mechanical, mechanical to electrical energy will be stored in the battery. While the battery is being charged, you cannot use that battery. So during that time, an auxiliary power supply like supercapacitor will take over. This is the first condition where supercapacitor is being used or ultra capacitor is being used. And the next state is whenever you accelerate more. For example, when you speed up your vehicle, it may take more charge. During that time, instead of getting it from the battery, it can get it from the ultra capacitor. This is the second condition. And the third condition is whenever you're climbing a hill, it may need more energy. So during that time, your ultra capacitor will support. The entire vehicle cannot run with the help of supercapacitor alone. So it will be a supporting mechanism for the battery or any other storage system. Yes, sir.
Good, sir. Clear, sir. Thank you, sir.
Okay, thank you. Any other questions, please?
This is Venkataraman, sir.
Sorry, come again.
Venkataraman, Dr. Venkataraman.
Yes, sir, please.
As you said, we have a motor generator set. We are using DC motor and as well as AC motors, etc. And also corresponding topologies, DC to DC converter and inverter. What will be the consequences if we change the DC motor or AC motor? See, when you are using DC motor, you have to replace the DC converter, isn't it? And
Yeah.
when you are going for the AC, you may go with the multi-level motor, the various whatever. Try to give the proper explanation of these consequences.
Sir, let me reframe the question again. Tell me whether it is right. So you are asking me, there are different type of motor, DC motor and AC motor.
Yeah.
And for DC motor and AC motor, you use converters like DC to DC converter and DC to AC converter.
Yes.
And if you replace DC motor with AC motor, what will be the consequences? Am I right, sir?
Exactly.
So the concept is simple, sir. For example, DC motor, we will be using a DC voltage, but directly I cannot run my DC motor with a battery. So what I need is I need an interface. That interface is my DC to DC converter. So the DC to DC converter will act as a boost. Depending upon the voltage requirement of the motor, it boosts the voltage and it will give it to the motor, DC motor. So in that way, DC to DC converter will be used. If I replace the DC motor with an AC motor, I require an inverter because the DC will be again converted to AC. In that case, inverter alone won't be sufficient. The reason behind is the same. Directly I cannot give my 12 voltage DC to inverter. I can give, it is possible, we have different topologies to do so, but it is advisable to go with the DC to DC converter since my electric vehicle requires different DC supplies which cannot be directly supplied by the battery. So I'll be having some auxiliary loads apart from the motor load. So I'll be having a DC-DC converter. Then it will act as an SMPS, sir. In your computer, you have an SMPS, switched mode power supply. You may require a different voltage for the the processor, the keyboard, the mouse, etc. So that is being distributed by switched mode power supply. My DC-DC converter in an electric vehicle will act as a switched mode power supply, and from then it will give it to the inverter, then to the AC motor, sir. Have I answered your question?
Yes, sir. Yes, sir.
Okay, thank you. Any other questions, sir, please? Okay. Thanks for the questions. I'll move on to the next slide. So this is the another architecture of a hybrid electric drivetrain. There are 4 different hybrid electric vehicle architecture, basically a series parallel. And apart from that, depending upon the topology, depending upon the vendor, depending upon the car manufacturer, they have 4 kinds: series hybrid, parallel hybrid, series parallel hybrid, and complex. Here, the primary source will be the internal combustion engine. We have a generator, and we used to have a 2-level converter. For example, we'll be having a PWM converter, then it will be converted to the DC again convert to the AC by means of a PWM ESI, and then it will be given to the motor, transmission, and the corresponding transmission process will take place. So here again, it all depends upon how you are selecting the component, what type of motor you choose. We can go for different drivetrain. So here, one of the important point I missed is drivetrain. After seeing this title, I remember the drivetrain, the meaning of drivetrain is from the source, we have a load, from the source to the load. Here, the source is the battery. Let me take this slide. Here, the source is the internal combustion engine or the battery, and the load is the motor. From the source to the motor or load, we have different component, and all those components we used to call it as a drivetrain component. So when you choose or when you design your electric vehicle, you have to choose or design the drivetrain components properly. So if not, what will happen? The drivetrain component may stress, and it may lead to decrease the performance of the electric vehicle, and the overall efficiency we may get degraded, and the losses will become more. So drivetrain, the components involves the converter, the battery, everything. All the components, we call it as a drivetrain component. So while designing an electric motor, these are all the major requirements. We need high instant power and high power density. And this is critical. We need high torque at low speed for starting and climbing, as well as high power at high speed for cruising. Similarly, a wide speed range, including constant torque and constant power region, fast torque response. See, I think many of you people are working on SRM, switched reluctance motor. Switched reluctance motor will have very fast torque response. And now people are working on SRM. But the problem in SRM is it has high torque ripple content. It will do what? It will stress the drivetrain. If the ripple content is more, it may stress the drivetrain component and the performance will get degraded. How to avoid it? It can be one of your research objective. And designing a suitable switched reluctance motor using any of the lot of softwares are available. I don't need to tell these things to you. A lot of softwares available. You need to design proper SR, stator rotor poles of a SRM. If you increase the number of stator rotor pole, obviously the torque ripple content can be reduced, but the cost of the motor will get increased. The high weight of the motor, the mass become increased. So we need to optimize my system in such a way that even if I increase the stator rotor pole, it should have less torque ripple content so that it has high torque response. Okay. And the purpose of going SRM is this. And we have high efficiency over the wide speed and torque ranges, high efficiency for regenerative braking, and of course, reliability and robustness. These are all the main requirement of hybrid electric vehicle. So the current research, as I told you, how to reduce the weight of the vehicle. Because it almost like a bulletproof jacket. What is required for a bulletproof jacket? Electrically, if you speak, it is almost equivalent to the windmill, wind turbine, wind blade system. What is required for a wind blade? Technically, it should have less weight and at the same time high strength. What is required for a bulletproof jacket? It should have high strength as well as less weight. The material used for bulletproof jacket as well as for wind blade is Kevlar fiber or Kevlar fabric. Similarly, we can go for GFRP, glass fiber reinforced plastic, or simply FRP, fiber reinforced plastics. So we need to manufacture. This is not our area. This belongs to mechanical or automobile engineers area. But the requirement is somehow we need to reduce the mass of the vehicle. For example, if you reduce the mass of the vehicle, the torque requirement will be reduced. Similarly, the battery requirement will be reduced. Okay. So alternate to the battery, we have NiMH, nickel metal hydrate. It's quite costly, but now people are concentrating mostly on lithium family of battery, lithium phosphate, lithium ion battery. If anyone is interested, you can go and visit those factories in Coimbatore. In Coimbatore, we have few manufacturers. They are not manufacturing lithium ion. They are just purchasing it outside and they are assembling it. We are just assembling it. Okay, we are outsourcing it. And these are the degrees of hybridization we have: micro hybrid, mild hybrid, full hybrid, plug-in hybrid. These can be categorized by 5 parameters. How we are starting it, what type of regenerative braking, what type of motor we use, whether it is a combination of internal combustion engine motor and can drive at times using only the electric motor. What is the rechargeable methodology we choose? So based on that, the electric vehicle can be categorized as plug-in type, extended range type, battery electric vehicle type. And if you calculate the energy loss in the city driving, this is the slide we engineers must concentrate upon. This is the source, fuel tank, and we have the load, that is nothing but the transmission system. So in engine, we have some losses. In drivetrain, we have some losses. During the driving range, depending upon how you drive, how efficient you are in driving, we have few losses: aerodynamic losses, rolling losses, braking losses. Someone will drive a car always legs on the brake. Always they will have half clutch, right? And they will put brake very often. So these are all the drivetrain related losses. Okay. During the highway driving, we can avoid certain losses like standby losses, engine losses, driveline losses. These are all the losses we have. But in the case of a hybrid system, if we implement hybridization or automation, some of the losses we can able to eliminate. For example, micro hybrid can eliminate standby losses, and mild hybrid can reduce some of the driving losses, and full hybrid, the engine losses can be completely reduced. Okay, and plug-in losses also can be reduced. In the city driving, obviously it is not wise enough to compare the electric vehicle efficiency and the conventional vehicle efficiency. But even then, for the better understanding, I would like to show this slide, well to wheels efficiency. We have the first picture, which represents how power is being transmitted, generated, transmitted, distributed, and it is given to the electric vehicle. Similarly, in the case of a conventional system, it goes to the refining, transmission, and finally it comes to the wheel. Overall, if you see the efficiency of the vehicle, the electric vehicle approximately, leaving all technical aspect, if you bother only about the major losses, 23% will be the efficiency of an electric vehicle. And here the conventional vehicle will have only 13%. Okay, there are a lot of scopes to improve the efficiency of this 23%, but no more scope available for increasing the 13% efficiency of the conventional vehicle. Only option is to switch over to the electric vehicle concept. And some of the terminology you need to know. We have studied now the basic architecture structure of an electric vehicle. And some of the terminologies are state of charge, state of health, depth of discharge. Apart from these three, we have SOAP, state of average power. Rest of the things you know, basic electric terminologies. So I'll tell you what is the difference between state of charge and state of health. If you have a mobile phone, you just see it now. If you see at the top of the mobile phone, the battery percentage, that is equivalent to the state of charge. At what percentage the battery is being charged, the 40%, 60%, 90%, 100%. Meaning is battery is charged to the level of 100%. And what do you mean by state of health? So you are using this mobile phone for, let us say, for 5 years, 10 years, etc. During the first year, the health of the battery might be 100% or 95%. But because of your usage, because of your more screen time, because of more charging and discharging of the battery, the health of the battery may get degraded. So that is nothing but the state of health. In a very precise way, if I want to tell it in a colloquial manner, assuming that you are having a car and you have 2 meters, odometer and a speedometer. The speedometer is the one at what speed you are driving the vehicle at that instant of time. Let us say 80 kilometers per hour. It is equivalent to the state of charge. And you have purchased the vehicle 5 years back and you have driven a particular kilometer, let us say 1 lakh kilometer. So that is equivalent to the state of health. Do you have any doubt here? I have given an example for state of charge and state of health. This is a very, very important point for designing the BMS of a battery management system. If you have any doubt, you please tell me now. Okay, I think there is no doubt. Let me move on to the next slide. So hybrid electric vehicle objectives are maximize fuel economy, minimize fuel emissions, minimize propulsion system, and maintain performance. And these are all the hybrid electric vehicle advantages, like regenerative braking is possible, reduction in engine and vehicle weight, fuel efficiency can be increased, emissions can be decreased, etc. And these are all the corresponding drivetrain component. The first one is the motor, second one is the energy system, third hybrid power unit, and the fourth is transmission. As I told you, there are different types of motor is being used in electric vehicle. In short, AC and DC. Apart from that, we have different motors like forklift motor, hub motor, synchronous reluctance motor, switch reluctance motor, permanent magnet synchronous motor, brushless DC motor, etc. Depending upon the type of the motor, we choose the proper controller. For example, if it is a DC motor, battery is the source, motor is the load. I can control the motor with the help of a controller. I can give the input to the controller through the pedal mechanism. Speed and torque is being controlled by the pedal. And in the case of an AC motor, the same thing. I have a battery, controller, AC motor, and this controller gets the input from the user. And motor component, I can skip it. This is simple. And energy storage system, as I told you, we have lithium-ion, nickel metal hydride battery. We have ultra capacitors, we have discussed already, and we have flywheel. Flywheel is a very old concept, and it is not practically possible as well. Flywheel is something like the kinetic energy can be converted to electrical energy. It is quite complex, practically not feasible. And advantages are it does not have any acid or hazardous material, unlike battery, because Ola cars have faced a huge problem because of the battery, right? Those problems can be avoided if you have flywheel concept for energy storage, but that is not practically possible. And how do I choose the battery? And it is entirely based on charging and discharging the battery. So how my battery will perform when I drive my vehicle at a very low speed. And during city driving, I'll often apply brake. And what is the performance of the battery? And during highway driving, I won't even apply a brake. I'll be driving at a constant speed. And during that time, how my vehicle performance? What is the vehicle perform? And during uphill driving, how it will react. And during coasting, slowing, and stopping. Coasting means not at a very high speed, not at a very low speed. Slowing means driving at a very 10 kilometers per hour. Stopping means 0 kilometers per hour. So during these conditions, how the battery performance will vary. Depending on these aspects, I need to choose the battery. So regenerative braking, as I told you, whenever I apply a brake, the energy will be converted to mechanical energy, and that can be used for recharging the battery. And 4 type of hybrid power units available: compression ignition system, spark ignition system, gas turbine, and fuel cells. Okay, and these things are very basic, which is used in the car. And the transmission also, we have 4 things: CVT, all the cars which is available in the market, we have continuous variable transmission, and automatic gear transmission, torque based transmission, and manual transmission. In all this type, it is possible to implement the concept of electric vehicle. And now let us move on to the next topic, the converter. Let me have a break, 5 minutes break. Then we'll move on to the converter. Meanwhile, if you have any questions, you can ask me now. Any questions so far? Okay, if not, let us have a break for 10 minutes. Now time is 8:15. Let us resume back at 8:25. I mean 8:20. Yeah, 8:25 again. Thank you all.
Okay. I request all the participants to assemble back by 8:25.
Sir, can we start now?
Yes, sir, we can start, sir.
Yeah. So far we have discussed about all the important drivetrain component. Now one of the important topic is the converter. Like as I said earlier, converter is being used for 2 things. One is for controlling the motor, another one is for battery management system. And out of all this, DC to DC converter is an important topic because the source is DC, and that has to be converted to a required DC, so DC voltage based on the motor or for the auxiliary loads. For that, we are using different type of topology. And before that, let us see what are the different types of converters available, which is being used for electric vehicle applications. We have AC to AC converter, DC to DC converter, AC to DC, DC to AC. And all these type of topologies are being used in electric vehicle for different applications. And the basic requirement of electric vehicle converters are, it should be of a lightweight. As I said, weight is a main criteria. If you choose more number of switches, we require more heat sinks and the weight will be increased. And it should have high efficiency, small volume. And one more important point is EMI. It should have low electromagnetic interference. This is going to be the topic of future. All the devices which has power semiconductors will have the problem of EMI. And it has to be mitigated properly. Even if your mobile phone will have EMI problem, mobile phone towers will have EMI problem. Wherever you have semiconductor devices, it will have some electromagnetic interference. Mobile phone will have SAR, specific absorption rate. All these things has to be mitigated properly. Otherwise, it will have adverse effects for human being as well as for the as well as for the device. So it should have low EMI, and it should have low current, and it should have the proper control mechanism for the wide range of voltage applications. So while choosing a converter, I have given different converter topology. For choosing a different converters, you need to specify properly the requirement. Based on the requirement only, you will choose the converter. So advantages and its corresponding drawbacks are, the advantages, as you see, based on the motor voltage, we can able to switch to different voltages range. And the drawbacks are, in a simpler way, it may emit radiation, and we need to give proper thermal protection, and it has some interferences, it has some harmonics. All these things has to be filtered it out. Why I need a DC-DC converter for an electric vehicle? This can be explained with a simple diagram. See, I have two sources, fuel cell and a battery. Let me check this here. Okay. I have fuel cell, supercapacitor and battery, and I have one motor. So whatever may be the sources, it has to be converted to a required voltage by a DC-DC converter. Then it will be given to a common DC bus, and I will give this to a DC to AC inverter, then it will run some motor. And if it is an induction motor, I will again give back to the battery with the help of bidirectional DC to DC converter, that we call it as a BDC. So for an electric vehicle application, we need a bidirectional DC to DC converter. So there are two types of bridge converter, half bridge converter and full bridge converter. Okay, in this we have bidirectional DC to DC converter. Again, here we have two classification, non-isolated type and isolated type. So the selection of proper converter all depends upon the application and the type of motor choose, and based on the requirement and based on the design parameter. So I can choose any kind type of a converter, but what is the output? What is the outcome? So that has to be designed, checked properly. So some of the hybrid electric vehicle challenges are the storage, energy storage devices with high power to energy ratios, frequent shutdown and startup of the hybrid electric vehicle, how to reduce the size, weight and cost, and efficiency, of course the configuration. And the second important one is the safety aspect. See, whenever cars met with an accident, what will happen to the battery? You are running your car with a bomb. It's almost like that, right? You have a heavy sized battery, and what happens if it bursts out because of the accident? To safeguard you, you have an airbag, but that is not sufficient enough, right? So each and every battery has to be checked for 8G crash load rating. Even if there is a crash of 8G, your battery won't get affected and it will be in the safer side. Apart from that, the battery will have some spillages, lead acid battery or lithium-ion battery. Lithium-ion battery is completely packed. Apart from that, we have a SMF, sealed maintenance-free battery. But even then, we'll be having some spillages because of the improper maintenance of the battery. So during that case, how will I safeguard myself or safeguard the components in the vehicle? For that, we need proper switchgear component like circuit breaker, fuses, relays, contactors, etc. So again, the proper selection, design is a very important point for the safety aspect. Everything should work on FOS. Otherwise, no point in designing the system. And the performance of the electric vehicle can be characterized by different parameters. First one is acceleration and speed. So how fast my vehicle will move from 0 to particular speed, let us say 0 to 60 kilometers per hour. How many seconds it requires to move from 0 to 60, and at what speed I can run my vehicle. Either it could be 150 kilometers per hour, 200 kilometers per hour. What is the speed maximum range? And how long I can run my vehicle without charging it? What is the discharging capacity of my vehicle? DOD, depth of discharge of my vehicle. Let us say I am running at 120 kilometers. I can run. The present day vehicle, they are claiming that 100 kilometers you can run without charging it. During the 100th kilometer, you need a charging station. Otherwise, I will not prefer electric vehicle, right? So what is the speed range? What is the range? So the first one is the acceleration. The second one is the speed. Third one is the range. And the fourth one is the emission rate. Of course, it will be obviously lesser. We have a table. So when you compare diesel and electric vehicle, the emission rate is very, very low. Some of the pollutant are carbon dioxide, carbon monoxide, NOx, SOx, hydrocarbon particulates, NOx, SOx. So these are all the pollutants you need to check, and it should be in terms of grams per mile. Okay, it should be lesser than the predetermined level. Obviously, it will be lesser for electric vehicle when compared to diesel or petrol vehicle. Okay, and another important concept is vehicle to electric or vehicle to grid or grid to vehicle. I think this topic is being covered somewhere in any of the session, but even then I would like to give a small introduction about it. Vehicle to grid is your vehicle could able to give some supply to the grid back. Grid requires AC, your vehicle will give DC. So you need a DC to AC converter. And from that AC, you need a AC to AC converter. So because of that, we need all type of converter for electric vehicle technology. Now you will understand the importance of the slide, what I have shown, different converters used for electric vehicle. So the concept of V2G is your vehicle can give extra power. Let us say your vehicle is completely covered with solar PV system. Solar PV panel is being used to charge your battery. And after that, extra power can be going waste, right? Instead, what you can do is like you can give back to the grid with the proper DC to DC converter and the DC to AC and AC to AC converter. That concept we call it as a vehicle to grid technology. Similarly, grid to vehicle is something like from the grid, you will be charging your vehicle, charging the battery which is being used for the vehicle. So that is called as grid to vehicle technology. Some of the challenges of electric vehicle are limited range. I can use this vehicle only for a limited range. And people now claims that 10 minutes is required for charging it, 10 to 15 minutes. And I don't need to spend much time in charging my vehicle. Initial cost of the vehicle is high. And I can maximum use this battery for 5 years, 6 years maximum. How to increase the battery life? And the consumer should be ready enough to accept the electric vehicle concept. And how can I integrate into the grid? So these are all the challenges. So meet out the challenges. Some of the solutions readily available are, instead of fast charging, as I told you, you can go for battery swapping. So swapping time is minimal when compared to the charging time. So another one is rapid charging. People now call the concept called as turbo charging, fast charging, rapid charging, super fast charging, and it can charge your vehicle in less than 10 minutes, right? So improve the charging methodology so that the charging time can be minimized. And as I told you, lithium family batteries are available in the market, which has certain advantages like it is completely recoverable and recyclable. And we can extend the battery life based on the usages. We can implement proper BMS, battery management system, so that the performance of the battery can be increased, the life can be increased, efficiency can be increased, losses can be reduced, and weight per volume reductions and alternate chemistries are required to replace the conventional battery system so that the expectancy life can be increased. Initial cost, we don't have anything to do with that. And electric vehicle charging infrastructure can be classified into two: AC charging infrastructure and DC charging infrastructure. In AC, we have level 1 and level 2, and these levels can be classified based on the power requirement, the torque requirement, as well as the charging time. So conventionally, people prefer AC charging, and if you have solar PV system or for a public utility system, we can have a DC fast charging methodology. So charging location is also being planned or standardized, where we can have the charging station. Assuming that I have a vehicle and I'm charging using a public transportation system or a public charging system, whom should I pay for it? Or otherwise I'm charging in my neighbor's home. How should I pay to them? So these are all some of the basic protocols need to be addressed by the government so that everyone can use it. Limitations of electric vehicle are classified into three: social problem, technical problem, and economic problem. Economic problem, leave it. Social problem are acceptance by the people. There is no awareness. Even though there are awareness, technically there are certain hiccups which may make the people to avoid buying electric vehicle. And insufficient charging station. As I told you, let us say 100th kilometer, my vehicle is completely discharged. Then is there any sufficient charging locations available? How to find out this charging station? For this, we may use artificial intelligence technique. And what are all the technical problem, like the limited range, long charging time, and some of the safety issues? And what is the impact of EV on power grid, environment, and economy? Impact on power grid is the concept we electrical engineers needs to be concentrate upon. It has both positive and negative impact. Positive impact, of course, we can connect directly to the grid, vehicle to G. and facilitating smart grid concepts. We can easily integrate renewable energy systems. Some of the negative impacts are what happens if all the vehicle comes and charge at a particular charging station? What will be the impact of all the vehicle charging methodology and how it affects the local distribution transformer, local grid, and some of the harmonic indices like harmonics, voltage sag, how it can be addressed, and how overloading of transformer can be avoided. So these are all the points the researcher has to think upon, and they have to give a proper solution. This should be the takeaway from this presentation. How these negative impacts can be addressed by the faculty member. And these are some of the industries, and these are the factors influencing in India for improving electric vehicle. We need a proper infrastructural development. We need a proper revenue model and monetization for charging methodology. We need to build consumer awareness, and it should be completely accepted by the community. And what are the regulatory and compliance support available for electric vehicle? So in conclusion, we need proper power design engineers to provide support the design performance of the vehicle, and we need a proper EV battery packs which can be connected in series and parallel depending upon the capacity of the motor and depending upon the capacity of the battery. And of course, we need, wherever you have a battery, group of battery or a single battery, we need a proper BMS. And BMS involve a lot of components, a lot of parameter. And depending upon the complexity of the parameter, we can choose any controller, right from Atmeha to STM32. STM32 is the most preferred controller in the industry side for developing a battery management system. And we need a proper microcontroller unit for controlling all the control algorithm. Okay, so with this, I would like to stop my presentation. Some of the topics will be covered later, like wireless power transfer, everything I will cover it later. And I told you I will share the book maybe during offline presentation. I'll share more books, but currently I don't have it right now. Let me check in the next slide. No, not this one. Yeah, so these are all some of the books I have authored, and out of that, which is more related to electric vehicle concept, is this power converters for electric vehicle. As I told you, I have given the complete introduction of requirement of power converters for electric vehicle, designing of electric vehicle converters, etc. Similarly, the deep learning concept is published in Wiley. How deep learning is useful for electrical engineers. How do you write a program using Python for deep learning, and how do predictive analytics play an important role? This is published in Nova. Like we have given different use cases for decision making, and this is yet another book in Python. It is also based on deep learning concept, and this is based on machine learning. So this book I would like to share it during the details of the book. I would like to share it during the offline presentation. So with this, I thank Dr. Kannan for inviting me. And I thank all the participants for your active participation. Maybe we can discuss more on these concepts, everything during the offline presentation. And if you need any clarifications, any of the topic what I have discussed, you please contact me in this number. So thank you all. And if you have any doubts now, please open up. I would like to answer all. Thank you.
Thank you, sir. Thank you for your nice presentation. Since the participants from computer science, mechanical, electrical, and a few research scholars, so mixed up participants are attending this program. You have explained it in simple to complex. I hope this will be benefited for all the participants. Now it is a question and answer session. Participants, please feel free to ask the questions. Sir is ready to answer all your questions. Please.
Sir, excuse me. Hello.
Yes, sir, please.
Yes.
Sir, I am Karpia from PSG College of Engineering. Sir, I have a doubt.
Yes,
sir.
sir,
Yes.
please.
while charging the system. So what kind of
Sir, your voice is not clear, sir. It is breaking,
Sir?
sir. Yes, sir. Your voice is breaking.
sir?
Yes, sir. Tell me, sir.
Sir, are you hear me?
Yes, sir. Now it is clear. Tell me.
Sir, while charging the EV, some motorbikes may be blasted like that. We can read that messages from newspapers. So what kind of mistakes are occurred that time?
Sir,
Why
that
it
is
will
because
blast
of
during?
the no. That is because of the improper battery management system. As I told you, if you don't have proper battery management system, battery cannot be maintained properly. So,
Sir, is any cooling systems available there for battery?
As I told you, thermal management system is available dedicatedly for batteries in the cars. It is a
Thermal
separate.
management means any cooling paste or other thermal materials
Both are
like
available.
Peltier module like that.
Sir, for your sir, for your kind information, we have one separate session for this thermal thermal
Oh,
battery.
okay, sir. Okay, sir. Okay.
Dinesh
Hello, sir.
Sir, sir.
will be there in the offline session, sir.
Okay, sir. Thank you, sir. Thank you, sir.
Yes, sir. Any other questions?
Sir, I am having one
Participants,
question. Sir, how many percentage can we concentrate on to design the battery while designing the electric vehicle?
No, there is no percentage wise, but
So that I am asking, what are you given? So that I am asking.
sorry, sir. Come again.
So in the electric vehicle design, so how much of percentage can we concentrate on the battery design?
No, battery, we are not chemistry based, right? First of all.
Okay. Okay, sir.
So,
So that
we
means
have-
I am asking that. So in a scale of 10, so I am giving some percentage to the electric vehicle design. So how much of mark can we give for battery?
10, sir. Of course, 10.
10.
Battery is the
Okay.
main source for your electric vehicle. Without
Okay.
that, your battery will not run.
Okay, sir. Okay.
Without that, your motor will not run. Okay.
Okay,
So
sir.
there are different type of batteries available, different sources available. So
Okay, sir.
whether your battery can able to give the required power or different required ampere hour for the motor, all depends upon which battery you are choosing.
Oh, okay, sir. Okay. Okay.
We are not here to change the chemistry behind the battery. There are certain batteries available. We are not specialist in designing a battery. There are batteries available. With that available sources, how best we can do it? That is the scope of our research. Maybe chemistry
Okay.
people, physics people can concentrate more on the battery design, etc. Battery design aspects, etc. But as an electrical engineer, with that available sources, how best we can do it? That is the scope of our research.
Okay, sir. Thank you.
Hello, sir.
Good evening, sir.
Yes, ma'am.
Yes, sir. This is Indumati, sir.
Yes,
Sir, what is the scope for designing a battery management system using FPGA, sir?
Ma'am, lot of scope is available, ma'am. Like,
Yes.
for example, in battery, we need to monitor 3 parameter: voltage, current, temperature. These are all the
Yes,
3 parameters to be monitored, and
Yes.
individual cell level voltage, current, and the temperature has to be monitored. Okay. So all these parameters has to be given to the controller. One. For that simple, Atmeha 8051 controller is enough. That might be the first thinking. But
Yes.
why
Yes.
FPGA is required is we can able to predict when the battery will die. We can able to give an alarm to the user. If
Yes,
one
move
of
it. Yes.
yeah, well, let us say we have 10 cells. If any
Yes.
one cell got degraded, remaining 9 cells will get degraded very quickly. But as a user, we may not know which cell got degraded. So
Okay,
that
sir.
has to be given as an input to the user by the controller. So this is why BMS plays an important role, and this is why FPGA and everything is required for battery management system.
Okay, okay, sir. Okay, thank you, sir.
Okay.
Hello, sir.
Yes, sir.
Shall I know which converter, which family of converter is presently in the EV vehicle? As you know, as you said, different types of converters, inverter, multi-level inverter, various types of converters isn't it? No? I'm moving to AC converters, DC to AC converters. Which type of converter is presently available?
DC to AC, sir.
Yeah, exactly.
Sir, multi-level inverter is available, sir.
Why don't we move towards the Z source inverter? Because
Yeah, of course we can.
We can boost up the voltage, you know.
Yeah, of course. You can go for Z source inverter. You can go for quasi. We can go for zeta in the case of DC to DC. We see it's all depends upon the user and depends upon the complexity of the control algorithm, sir. I can say in my usage, in my experience, I can say that the PWM inverter is the best one.
MLA is the best one.
Yeah, but no, for example, I'm saying you may say that Z source may be the best one. It's all depends upon how well you are designing the inverter.
Okay.
Anything is good, sir.
Yes, but a lot of consequences, a lot of problems in the Z source side. That's why just we are moving towards the PWM.
Yes, sir. Yes, sir. Exactly.
Exactly.
Sir, I have
thanks. Actually, a lot of people are asking questions. I'm happy that many of you have listened the presentation.
Yes. Sir, I have one question.
Yes, sir, please.
The LPG cylinder, how we are changing in our house. So like that, the battery swapping technology, what are all the problems associated with that battery swapping technology, sir?
Yes, sir. Actually, battery swapping is one of the easiest solution that might be useful for public buses. For example, the bus will run in a shift basis. Morning 6 o'clock to 2 o'clock, the battery, the battery is sufficient enough. And while waiting for a lunchtime, the battery can be swapped. So this is good for a public buses. But in the case of a car, as I told you, mine is a new battery. When I swap it with the old battery, it is a loss to me, right?
Yes. That is.
These are all some of the basic problems we face while we use a battery swapping technology. In the case of an apartment, it may be good. In the case of a common workplace, it might be a common because anyway I'll be using the same battery again and again. It will be used by the same user again and again. So we need to formulate a rule for a battery swapping technology. Then it will be a successful model.
Yes, sir. Any other problem other than this, sir?
No, nothing, sir. No other problem, because it is one of the easiest mode of quick charging method.
Yes, sir. The charging problems are nullified if you are.
Yes, sir. Any other?
Sir, this is Saktivel from PSG College of Technology.
Yes, sir.
Which type of electrical vehicle is best, sir?
Which type means? Sorry, I couldn't understand the question.
Which type of electrical vehicle, sir? So many vehicles are there, different types, you know.
He's asking about this hybrid and this some models you shown now, sir.
Yeah. See, each and every vehicle, if you go for range extended electric vehicle, meaning is what? You have a source. Apart from the battery, you will have another source, ultra capacitor or super capacitor. Then in that case, the cost will be more. The test vehicle will be a complete battery electric vehicle. It is a cost-effective vehicle. Complete battery electric vehicle. Fuel cell, we have some problem like what will happen to the hot water which is being coming out from the fuel cell. There are few issues in fuel cell. The complete battery, full battery electric vehicle is the advantageous and cost-effective one.
Okay, sir. Okay. Okay. Thank you, sir. Thank you.
Any other questions from participant side? If there is no other question, we will wind up the session. Sir, thank you very much once again for answering all our questions, and we have taken some points by means of this session. I wholeheartedly thank you for sharing your valuable time, because whenever I am talking about you, the people around you tell sir is always busy. So getting this time is very difficult. So this is the comment, point I received about you. So even my daughter is also told, if I am going to meet sir, sir is always busy. So for sparing your valuable time, particularly in the evening times. So thank you very much, sir. We will meet you in the offline session so we can have more interaction. Right? Okay, thank you very much, all the participants. So tomorrow's session, it will be handled by Dr. C. Govindaraju, Associate Professor of the Triple Department in Government College of Engineering, Salem. He is going to talk about fuel cell electric vehicles. So I thank all the participants in the late evening. Okay, once again, I thank you all. Okay, we will, with this closing note, we will wind up the session. Thank you very much.
Thank you, sir. Thank you all participants. Thanks for the opportunity. Thank you all.